Standards Practice Week 3. Tamika is buying snacks. She buys 6 apples and a juice. The juice costs $1.25. The total cost is $5.75. How much is 1 apple? So if we're looking at this, we are buying 2 different things. So apples and juice. So I'm going to say apples is X and the price of apples is X. And the price of juice will be Y. So that means 6X plus 1Y was $5.75. Well, it actually told us what the price of the juice is, which is $1.25. So 6x plus 1 times $1.25 equals $5.75. So 6x plus $1.25 equals 5.75. To get the variable by itself, I'm going to need to get rid of this positive 125, so I'm going to subtract 1.25 from each side, which will give me 450. So 6 apples cost $4.50. If I want to know the price per apple, I would need to divide both sides by 6, and that will tell me the price of 1 apple. Number 2. You can find the net force F on an object by using the formula F equals ma, where m is the mass of an object in kilograms, and a is the acceleration in meters per second squared. What is the mass of an object that has a net force of 72 kilograms meters per second squared and an acceleration of 6 meters per second squared? So if I know that it's F equals ma, it's easier if I know where all my units are. It says m is the mass of the object in kilograms, so m is just kilograms. Acceleration is in meters per second squared, so the a part is meters per second squared, which means this is the kilograms per meter times meters per second squared. So that'll actually tell me where to plug in everything I have. So what is the mass of an object? So I'm looking for this part. That's what I'm looking for. That has a net force, so the force is 72 kilograms per meter squared. Since I know my kilograms times meters per second squared is here, I know 72 goes here. I don't know my mass, so I'm going to leave it as m. An acceleration of 6 meters per second squared, so that goes here. So times 6. So if I need to figure out what the mass is, since it's mass times 6, to undo multiplication, I'm going to divide both sides by 6. And that'll give me the answer to mine, and it should be in kilograms, since mass is kilograms. Let's look at number 3. Write an equation to solve the problem. So I know that he is paying $6.50. And he's actually losing that money, so it's going to be negative because he's paying out of his pocket $6.50. But he's earning $32 for every shirt. So I'm going to add 32 for every shirt. The other one, he's paying $4.40 for a month, so he's actually losing $4.40 if he goes with the Broad Street store. But he's going to make a profit of $26 for every shirt. So plus 26x. So I want to know, when is this going to be equal? So this is the problem for A. So for B, it actually says solve for it. So let's solve this. We only want one variable and not on both sides, so I'm going to move one of them. I'm going to choose the 26x because it's smaller than 32. I'm going to subtract 26x from both sides. So this cancels out. I'm left with negative 650 plus the difference between 32 and 26, that is 6x, equals negative 440. Okay, if I'm solving this, I always want to do what's with the variable last. So how do I get rid of negative 650? Well, I add 650 to both sides. So I got 6x, these cancels out, equals negative 440 plus 650. That's the same thing as 650 minus 440, so that's 210. And then you would divide both sides by 6 to figure out what x is, and that will be the answer to that problem.